Hello, hello, hello. It's Progs, and wait, I don't remember which one it was that I was supposed to to boot. Oh no, I think it's this one. Yeah, it's this one. Okay, here we go. We have the music. Hey, a great beginning. Oh wait, I actually forgot. Do. Wait, the music is so loud. Wait, what? How is that possible? Wait, is it? I, I think it's fine. Yeah, let's say it's fine. So, okay, I have this, and here we go. So, yeah, hello. Hello, Ravioli. How are you? Professional streamer. Hi. Everything was just broken on my side. I wasn't ready to start, but that's fine. How is the volume, by the way? And how are you? Last time I tried to make those little animations, right? It doesn't work anymore. What if I start? I don't know what it's doing. Yeah, basically, it was very bad. It was broken. It was resetting the scale to 0 every time I tried to modify it. So let's just give up on that. That was a nice try. Let's call it um, trash. This is it. This is its destiny. And the new one is going to be the real overlay. I'm good. How are you? I'm good, thanks. Broken. Yay. Broken. Do you know how to say good in Japanese? You say Godot. Wait, does Google Translate does the same? Please, please. Wait. Ah, no, there's no traduction, direct translation like that. Stop, Lima, okay. I'm still mad about school. Okay, okay. I'll give you an easy one. Do you know about karaoke? Do you know how to say karaoke in Japanese? Overlay, let's remove this creator. And let's put some other stuff. So, wait, what? I think it was rigid body. Wait, actually, for. No, never mind. For placeholders, the. What was it? Which one was it? Collision? There's one basically that's good. I know. One thing that's good. But basically, it's in 3D. It's in 3D and not in 2D. So I thought I had it. No, okay. Karaoke is just well, I'm gonna write how it's pronounced, okay? Karaoke is pronounced like that in Japanese because it's a Japanese word. It was Japanese all along. What? Wait, I have a question. Okay, what is it? Let's put collision. I don't know. Creature, I have this one. Yeah, I guess it's rigid body 2D. Then I'm gonna just add a collision, collider, collision shape. That is like this. So yeah, I'm gonna have the ground, which is gonna be a sprite with some texture. Okay, let's have the collision under this. And can we make your sub badge a Pokeball? My sub. Wait, what is the sub badge again? Oh, wait. The wait. Is the badge, right? Wait, the sub badge. Wait, which one is it? I actually don't know because there's like copyright and stuff, right? And when you upload a texture on Twitch, you're supposed to say that you have the rights. So I'm not really sure. Yeah, okay. Wait. Oh, wait. You can change that. The little star. The star. Oh, okay. This. Oh, I see. I see. I mean, I could check. Yeah. I could. Oh, that's that's not the badge. That's me. How do you community? I'll have to check. I have to do so many new things. Maybe I just draw one myself because of the copyright. I just put some red and some white, and that's gonna be incredible. Oh, emotes drops rewards, power ups and channel points. No. I'll probably check it after the. Oh wait, actually, is it subscriptions? Emotes bonus. No. Oh, I get it. I have it. So subscriptions, subscriber badges, base 2 months, 3 months. Oh, so you know what? Like how mine are raviolis. Definitely not a Pokeball. Yeah, definitely not. Let's open the best. I was gonna open paint, but there's no transparency in that, right? So let's open a game, maybe. 2 seconds. Boo, boo, boo. Boo, boo, boo. In progress. Wait, in progress. I wanna make a Ditto Pokeball. Okay, here we go. Seconds. Let's have somewhat. Let's have this new. What was it? It was. Wait. What are the dimensions? 72 times 72. Got it. Here we go. Here it is. Let's create. Let's add the transparency layer. Let's remove this. And we are gonna make the best pixel art you've ever seen. Oh. That's not pixels. Wait, 72? There's like 72 pixels in that? Oh. Okay. So let's put like 5. Well, actually, we can probably just have a circle, right? How do we make a circle like this? We can have black. Then we can have. Wait, let's have different layers. I'm not comfortable with that. Then we're gonna have the same thing, but with white. Then the same thing. Wait, that feels wrong. Be right back, okay? Okay. Let's select this one. Wait, is that a pixel? Okay. Let's say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 4, 5. 2, 3, 4, 5, I think. So now we have. Wait, that's. Oh no. Oh no. Okay, that's good. Now we have white, please. Here. Now we have another one that's gonna be red. Maybe a bit darker than that. Red. Actually, red. Yeah, it looks good. So wait, the white was below, right? So I should select a rectangle like this. For the red, I remove. Then I have the wait. Actually, that's good already. Wait, that's good already. So now I take the black. Oh, right. Let's create another layer. Wait, that's not gonna be symmetric. Let's go with 4, so that we have 2 pixels on each side. Okay, here we go. Wait, yeah, that's fine. Wait, yeah. And the last one is going to be... It's a Voltorb. It's a Voltorb, it's gonna be a Voltorb. That's fine. We can go with this. Um, well, I was gonna, I was gonna call that not Pokeball, but like Prox Balls, but then I figured out that would be a bad idea for a name. Let's just call it Paul. Okay, okay. Okay, how is it going to turn out? So, 2 seconds. 72. Okay, wait, I have to do that for each one. Wait, what if I select this one? It's too big. Oh no. Wait, did I close? No, I didn't close it. So let's go back there. Let's... Can I duplicate? Hmm. I mean, I guess I'm just gonna save, you know, just in case. That's gonna be on the desktop. Why not? I'm gonna... Can I create from the same? No. Okay, let's... I love it. Okay, great. Great. I have so much talent. Okay. And now I have to just rescale. So this is image, that canvas size, but wait, scale image. So it's like 50%. It's like wait, 36, right? 36. Wait, is it? I think it is. This is perfect. Definitely not a Pokemon. Definitely not, right? You can see that. I can see that. Everyone can see that. Able to. And the last one is going to be even smaller. So, wait, actually, you know what? Oh, it's a bit too big. Can I with 2 maybe? Let's make it a bit better, shall we? Yes, wait. It's not aligned. I just realized. That's fine. Okay, it should be good. Let's export again. And then we have the final form, which is image scale 18. No. Yeah, 18. Okay. So we need a lot of we need to fix it. It's not good. one by one is gonna be great. Wait, I guess that's good. Perfect. This is perfection. This is symmetric still. And now we have this. Yeah, it's like that, or just like this, maybe? Like this? Big. Okay. Why is Electron smiling like that? Why not? I like these. Let me just think about the smile. The smile, the eyes. Like this. Oh, it's perfect. Great. Let's go with this, maybe. Okay. Export ball free. And I have the... I could actually like put some light on it. But for now, let's just keep it like that. Ball free. Okay. Upload badge. By uploading and saving these images, you are confirming that you own all rights to the images. Yeah, I do. I just created it live. That was live. And if you subscribe for 2 months, then you have not a Pokeball, not, well, you have another color of a Pokeball, maybe. I don't know, maybe I'm gonna have some chromas in the future. Wait, let me refresh the page. Oh, wait, actually there might be like some delay because Twitch has to review. Oh no, it's actually working right away. Crazy. That's crazy. Okay, great. And so the music is from Ender Lilies. Wait, you can't hear it. Can you? I like it a lot. So here it is. And now let's go back to programming. So we have stuff. What's your problem? Size changes to rigid body 2D will be overridden by the physics engine. Oh. Oh, yeah. Oh. Oh no. Okay, got it. So yeah, basically I should have something like that. And put one. The sprite is going to be different. Like this. And let's call it maybe a ground or something. Wait, is it too loud now? This is kind of threatening. This is gonna be fine. Get a bit forward. So let's just call it a wall. Let's call the new folder prefabs. Prefabs is a word I'm using from Unity because in Unity you know you have like nodes, I guess, but you can only save into prefabs or scenes. So that's why I'm calling that prefabs. In Unreal Engine, it's like actors, but you know, it's not really an actor. So I have my wall. I have my overlay, which is made of a wall. Wait, that's not what an overlay is supposed to be like. So now let's just scale that up. Wait, that's not how it's supposed to scale. Okay. Let's go with 200 and oh no. Oh, 205 maybe. Should be good. Great, we have a wall. Whew. So wait, what's your problem? Oh, oh, oh no. I mean, Oh no, it's not working as expected. Wait, what? Huh? Huh? Wait, how am I supposed to? Huh? I've never really. Hmm, that looks problematic. Do you know how to make walls on Godot? I feel so stupid. I've been using Godot for 2 years. Well, actually, maybe I guess one. Wait, how many years? 1 year, maybe? Wait. Well, 2 years actually. Yeah. So how? How am I making a wall? Tile map. I could use a tile map. Okay, let's expand. Maybe. Let's edit the children. Okay, never mind. Let's create another child here. Oh right. Oh no. Okay, this is complicated. This is the hardest problem I've ever had. Actually, I'm gonna search because this doesn't look good at all. Go to 2D, make a wall. Collision shape. Yeah, that's, I know. And time map is good. Yeah, maybe I should just use the time map. Drawing walls. How to make a wall. Am I really gonna watch that? Yes, I am. Oh. So, static body 2D, collision shape. So now you have a sprite. And how are you organizing that? Oh. Okay, okay, never mind. So you're putting the node 2D on top. Yeah, okay, makes sense. I hated making walls. Yeah, tile maps are like really good if you want to easily make stuff. You can basically just have your tile map somewhere, and well, I guess you need a tile set though. Fine, okay, no tile map for now. No tile maps. Yeah, so let's go back to our wall. Let's create a new node. Let's make root. Is there like a shortcut for that? Nope. Then we have the sprite, and it should be good. 20, 20, I guess that should be good, yeah. So now I go back here. I have the wall. And now I can scale up. Layers. 1, wait. 10. Okay, now there's no problem. Hey, here we go. Let's go with 100. Here we go. Yeah, I remember trying to make walls for my platformer Metroidvania, but like, you know, I tried to have, I basically wanted to have like curves or things like that, and I remember it was kind of horrible, and I just ended up with a tile map, I guess. So yeah, and also with the textures, it's like a bit complicated, right? Okay, so next step is we're gonna have something a bit different this time. We're gonna have a rigid body. Wait, actually, let's check. Body. I guess it's gonna be physics simulation. Yeah, let's have. I feel like that's gonna be wrong. Do I want this? Let's have a collision shape, which is going to be a circle. Let's also check the commands on the side, and so we have 20. Where is it? Oh, it's there. So we have our little bubble. Wait. So rigid body is not gonna fall, but this one is gonna have something, it's gonna do something, right? How do I keep the sprite in? I can just do this, I guess. Can I have a gradient 2D, which is gonna be radial? So I can have a circle. And transparent. Here we go. Wait. That's not good. Hey mate, I really love... Um, I received the exact same comments on Kick, but like 100 times more. So sorry about that, I'm already used to it. Okay, let's have... Oh, wait, I remember what it was. I have to set the... this one. It's like 005, for example. Now let's have something like this. Let's have something like this. It's gonna be white, and then we have this. And this is a circle. Woo! Yay! Perfect circle. The trash. So, wait. Why did I do that? Here. Okay. Let's have... This is not what I want. I want okay, textures. Yeah, this is so angry right now. I'm pro's #1 fan, get out of here! When I'm saying that, it feels like I'm very narcissistic. But, well. Yeah, here we go, we have the circle. Yes, that is a good circle. Just need a smile, some red, and... Okay, so we have the rigid body. Can we put the gravity? Oh, there is actually already gravity. Wait, so wait, what? Wait, so how? So it's just gonna fall if I start, right? Everything. So, well, wait, no, it's not. Wait, what? How is it? What? Wait, what? Okay, so I guess we have to check for collision layers, collision mask. And this is already good, I don't know what's going on. Okay, I want to try, so this is wall. What if I put this one here? Is it gonna touch something? I don't know. it's it's getting through. That stuff. Why is it not falling? I, that should fall, right? There's like gravity too. I don't know what's going on. Layer, mask. Do I have... I have the solver, I have activation, mass. You know what? When we don't know, let's check the documentation. Okay, this is gonna be very helpful. So, I can't read Chinese. Let's put this in English. Primitives. So we have those, convex collision shapes. Yeah, this is actually not what I want. I want rigid bodies. Well, bodies, actually. Here we go. It cannot be controlled directly. Oh no. Wait, that's kind of bad, isn't it? React to collisions. Yeah, that's kind of bad, actually. Uh-oh. You know what? Yeah, bro, Godot. I haven't. Okay, you know what? This Godot is so broken. Let's just remove that. Let's do our own thing the whole way. So we're gonna have, okay, we're still gonna have a circle, which is gonna be literally circle. We have a circle. I love it. Got my, what? Oh, not my, I got my Pokeball. Okay, I got you. Don't worry. So we have this, right? Maybe. So inside we are going to have, what is it gonna be? Key? Is that gonna be key? The key of a chain. You're gonna understand later. Don't worry about that. So then let's say we have multiple, so this is a key actually, this is not a circle. Let's say we have multiple keys like this. Oh, what? Okay, like this. And then we have, let's have a chain actually. Let's make a chain. The chain of change. So this is called the chain. Yeah, that don't actually need a script. This is gonna go in scripts. This one is. We're gonna have keys, so it's an array of node to these. Round I random color. Oh, not a bad idea. Thank you so much, Sweet Pro. You're welcome. Should I? Maybe. How do I switch like this? Okay. For now, let's just assign things. Key, key, key. And maybe we're just gonna generate them later on. So this is fine if we just have this. Let's actually have this maybe. Okay. So we have a chain. We have the keys, and now we are gonna have a process. Exactly what I wanted to do that the whole way, all along. 1, 2, 3, 4. I can count. Great. So I have to get the middle point of each segment. Okay, let's do that. Wait, that's inside. So for I in range keys that size, and we are gonna have update segment maybe for now. Really simple. I'm going at it the simple way at first. So the segment is gonna be actually it's like A, B. It's gonna be from the two nodes. We're gonna update it from I to I plus 1. So we're gonna have a -1 there to not go outside. And then we are gonna have another function here. So yeah, I was actually planning to do that all along. That's why I created a function. I knew it was going to be going to that. Last one is this. Wait, actually it's this dot back to keys dot front. And yeah, I actually have to check, well, to get the key right. So here it is. And now I have to get the middle point, which is global position, let's say. Yeah, let's work in global positions. Plus global position divided by 2. This is gonna be the middle point. And we're gonna have a maximum, is it too loud? No, okay, it's just in my headphone, maybe. So this is a vector 2. And the maximum oh, I love this music. Um, max distance is going to be something like 5. So now we're gonna compute the distance, which is going to be... Oh wait, do we have vector2 dot dist? Okay, a dot dist global position dot dist times... Okay, distance 2, great. So this is just Pythagoras, right? In a Euclidean world. Volume is fine, thanks. I really never know, because, you know, I don't have the same. Yeah, how do you do during your stream for the volume? I guess it's a bit complicated too, right? Let's put some floats. 5 is maybe too short, let's put 100. I just guess Lemao, yeah. Okay, same. I just look at the little, you know, in OBS you have the little thing that moves. And I'm like, okay, seems good. So we have the distance, or like the previous distance, I guess. And if this is higher than the max distance, then we are going to minus... Okay. Wait. What am I going to do? Wait, I have to get the vector, do I? Yeah, I remember that some people use the midpoint, but I actually don't really want to use the midpoint. Yeah, why? Yeah, in the video I watched, I remember that you had to compute the middle point, but no, you don't. Let's compute A, B, so this is A to B is B minus A. So A to B. This is a vector 2. I guess we have to get the... Well, to normalize, we have to normalize it. To, wait, unit. I guess normalized. Wait, there's no function directly. I mean, I guess that's fine. Let's just call that direction then. And it's normalized. You need someone... Wait. Until someone complains, Elmao. Okay. And now this is gonna be incredible. Maybe not. This is gonna be a dot global position plus equal the direction times... Let's have a delta. So delta is gonna be max minus this. Actually, did you know that if you compare to 0, it's like always faster? So you could actually put that here and then do something like delta is higher than 0. And that's kind of equal. Even like performance-wise, it's like maybe a bit more still, but like the compiler is really good to compare to 0. Well, not the compiler, the machine actually. Well, actually maybe both. Anyway. So we have the delta. We have the delta, so we can multiply by the delta, and we can do the same with b, but this is the opposite way, right? So this is minus. Yeah, I don't care about this. Let's try. Okay, what's going to happen? I don't know. Okay, that's kind of bad. 100. Yeah, maybe that's a bit too much. Maybe, wait. Yeah, maybe that's a bit too much. So let's go with 300, maybe? So nothing's going to happen, right? Because it's there. So now let's try to modify one of the keys, like keys dot front dot global position dot x plus equal delta times some speed, so like let's say 100 per second. And okay, it moves, and when it goes out of the range, okay, it just disappears. Yeah, there's definitely a problem with that. Yeah, there's a problem there. Oh, I know what the problem is. Well, actually, maybe I don't exactly, but I have an idea. I guess it has to do with the solver, right? So let's have. Yeah, maybe that's why you had to save the middle points. But no, that's wait. Actually, oh wait. So yeah, I have to save up the forces and do the movement afterward. Wait, I can think. I can't think. Um. So yeah, it should not set the position directly. I have to set the velocity, the direction. So like I have the velocity for each, I guess. Yeah, okay. I guess I have the velocity for each. Let's do this. Key velocities. So this is a vector 2. And we're then going to have key velocity. Wait, I need the indices though. So maybe just I is fine actually. I is gonna be fine. And this is key dot, well, keys dot size -1, and front is 0, please. Yeah. A is an integer, B is an integer. Maybe not. Yeah, maybe not. Let's do keys I. Let's do the same for B. So J. So I and J should be good. Yeah, it's an integer. Great. And now what we need is we have to set the velocity instead. So let's make sure that this is the same size as keys. And let's then, I mean, I guess I kind of want to reset it at the end. So let's do just that. Ideally, if you want performance, you should not reset the vector. You should not, wait, actually, resize. Anyway, yeah, you should keep the memory, but that's fine. It's practical. We're just prototyping. I'm basically making a physics engine. So so yeah. I'm making a physics engine because I want my custom thing that doesn't have the bugs that Godot has. And I velocity I. So this is gonna be the plus equal. Then I'm going to have the same with J, but with the minus, right? So it's going to try to go in different directions. Okay. It's not really segments then, but that's fine. Well, yeah, let's keep it like that. And at the end, when we have updated all the velocities, that should be kind of good, and we should be able to look through the keys again, like this, but all this time. And we have keys I dot global position plus equal key velocities I dot, well, actually that's it, right? But we have to multiply by the delta time to be careful about the frame, right? Actually, it should be in physics, right? Because it's like a physics thing. I'm just making my physics again. Yeah, let's go in physics. Let's go in the physics process, actually. Should be better. And now we should have... I mean, it kind of looks good. I guess I'm doing the velvet thing right now. Okay. Not even. I'm not having the acceleration. That's fine. Okay, so we have this. It's moving. It's moving, moving. Ooh. What's happening? Oh no. It's mad. It's just breaking apart. Maybe because this is the wrong directions? Oh, it's moving. Yeah, it is. Better, but still not good. So it's going from A to B. Ends to A. We add A to B. Times delta. Wait, oh, this delta, yeah. Max distance minus previous distance. Oh, wait, no. Wait, this is when previous distance is higher than max distance. Yeah, okay, that makes sense. Oh, in that case, yeah, it's the opposite, and that's why it was going the opposite way. Because, yeah, of course, it was becoming a minus, so delta was negative and it was changing everything. But now it should be good. Look at this. Going to the right. And now it's going to follow. Right? It's following, right? And then you're going to have... just wait a little bit. In some seconds, you're going to see something incredible. The last point is following too, right? So this is great. Hey, we have this. Great. So now I kind of... I kind of want to make my own collisions, but I feel like that's going to be overkill. I kind of want to reuse the collisions from Godot because they're kind of good. And they have like, circle optimizations. So that's great. I guess it's like character body maybe? Specialized for character moved by scripts, and now meant to be user controlled. They're not affected by physics at all. So basically my physics they're going to be affected by. But they affect other physics bodies in their path. Oh. Yeah, let's maybe try this. Animated, wait, what is this one? Let's just use the character body for now, maybe. So I think this is supposed to be the main... Wait, what? The main... the parent? Okay, so... Okay, this is gonna be fine. Do you trust me? Do you believe in me? Oh, wrong size. 30. Perfect. So now we're just going to copy that 4 times. And you thought I was gonna keep the sprites. Wait, actually I'm gonna keep the sprites. Stuff like this. But I'm just going to reset the position of each one. I can't multi-edit. Oh, I can. Wait, what? Oh, never mind. Yeah, okay, let's reset. Yeah, let's remove the scripts too, they're like useless. Yeah, yeah, that's bad. Let's remove everything. So we have this. We remove the key. We can move this again. No, not you. Wait, you know what? Let's just create a new prefab. Let's call that a key. Let's call that the sprite study. Prefab key. Okay. Let's remove, I guess. Oh. Let's remove. So now we're gonna have the same, but instead it's going to be a character body 2D. Maybe. I hope that's gonna be fine. We're gonna have 1, 2, 3, 4, probably. I'm going to put the wall again. Let's hope it works this time. Yeah, I'm not moving it, so that should be good, right? Wait, can I get path? Yeah, let's say it's fine. It's fine, it's gonna be fine. So now I have 1, 2, 3, 4, like this. And each one should be falling under, but should be falling under gravity. So I guess I have to set it myself. I have to do that myself because it's set by the user script, right? So in physics process, I should have character body. Instead of setting the global position, and well, yeah, instead of setting that, I should just set his I dot velocity equal the velocity I kept. So yeah, this array is actually not needed, but that's fine. And then, okay, I can update. No, I won't. Yeah, I have to set the gravity, right? So let's. Do I have a gravity? I don't. Gravity, velocity, acceleration. Actually, this is. So this is vector 2, 0 minus 100, maybe. Well, maybe minus 20. I don't know how fast it is. I guess that's fine. My whole heart. Are you ready? Are you ready? Let's put some acceleration. And let's add it to wait, I don't need to multiply by the delta actually. Wait, can I set the acceleration there? Ready! The second I have to set the acceleration, I can't. Okay, so this is just plus gravity acceleration times delta. Okay, here we go. Let's try. What? He's not doing anything. Wait, is it? No, it's... Wait, what? Plus gravity acceleration times delta. Should be good. Because... Oh, maybe I'm not updating the... Maybe I have to update the velocity myself. Or like the position, I mean. Let me check this. Current velocity vector in pixels per second, used and modified during calls to move and slide. Oh, right, I have to call this to call this. So move and slide is the one modifying the position. Move and slide. Here we go. Should be good. It's not. It's not. What's wrong? Returns true is the body collided. False overrise. Wait, that's not the one I want. Velocity is the body. Yes. To get the latest collision and call. No. That's true. So yeah, it should be moving with nothing right now. So why is it not moving? Let's put a breakpoint. Let's continue for now. And oh, maybe the sprite is just not following. Wait, I'm equal velocity? Wait, that's not what I want, right? I want a plus equal. Wait. No, that depends. Oh. Oh, that's why. Oh. Oh, okay. Okay, I get it. I get it. Um, okay, I get it. Yeah, I have to plus. I have to. I need the plus. So if I do the plus, that means I need to. That means I count that as an acceleration because I have to plus equal the acceleration, but I have to keep this one too, right? So that's why it wasn't going very well. Okay, here we go. Okay, wait, that's not the that's not how gravity is supposed to work. That's the opposite way. Okay, here we go. No, we don't. You know what? Maybe gravity is just a scam after all. It's just a scam. Who needs gravity? Yeah, you're right. Let's instead have. Um, I just realized something else. Okay, let's have his. Well, the first one, front. Dot global position equal keys dot front dot mouse. Get global mouse position and should be kind of good. There should be like some problems, but now I should be able to drag. Actually, no. Oh no. Oh no. Why? Relative to the canvas layer. What? For screen space coordinates, you can use this. Okay. Get global. No. Wait. Canvas layer. Yeah, I don't have a canvas layer, so that's not going to work. So Godot gets mouse position relative to node 2D. Yeah, I mean, is it really what I... The mouse position in global world coordinates. You can then convert. Yeah, but I mean, I'm setting the global position, right? Hmm. Let's try this. Let's try this. Huh. And why is it like, why is that like a white little square? That's so weird. Wait, let me check again. Godot set object, well, set node to global mouse position. Okay, let's check Reddit because, you know, AIs can be wrong, but Reddit can never be wrong, right? Okay, I guess you would want to move a node to where your mouse is on the graph. This is the solution. Or maybe, yeah, I need to account for the zoom. Oh, yeah, that's it. I have to get the camera, actually. Well, actually, I can just get it from my script directly, I think. But let's give it a reference, I guess. Maybe not. I don't want a reference. Let's do get viewport. Dot get camera 2D. Get mouse. Is it gonna work this time? No, it's not. Um, mouse position. And what if I do a get mouse position? Wait, please go back. Go back. Okay, get mouse position in the viewport. Do I have the transform of the camera? I feel like I'm going to overkill things. Mouse position? I mean, maybe the get local mouse position is for the best then. If it's... Yeah, let's actually try position equal get local mouse position. It's not good. Wait, it's actually working, kind of. Not really, but kind of. Right? Kind of. Now I have like two... What are they doing? Oh, right, I forgot. Wait, but what? Why is it not... Why is it changing every frame? That's kind of weird, right? But basically the goal is when I do this... Okay, let's get to the truth of this world. When we do this, we have... that stuff happening. Hey! Okay. Okay. We can try something else. Maybe. Maybe not. No. Hmm. I can have a dot velocity, maybe? Wait. Let's try key velocities dot front plus equal. So that's actually an acceleration. That's fine. So like this minus this, and I guess that's it. Is that it? Only identifier and substitution can be used. Oh, right. What? Identifier attribute access. So if I do like, okay, got it. If I do this, that should be good, right? Please. Please. No. It's actually kind of doing things. Oh, and there are collisions. It's really bad, but but yeah. Okay, wait. Oh, drink. Okay, thanks. So let's do a Godot drag sprite 2D, and I should have the answer to all of my questions with this. Did you know that in French, drag means to flirt? That's incredible. To drag someone is to flirt with someone. It's written. Wait. It's written. Like this. It's like a dag. Wait, how do you write dagger? Oh, never mind. Oh yeah. Okay, dag is in French. Okay. Yeah. Anyway, so Let's check this. There's nothing. Tutorial. So wait, we have all of this, mouse offset. Get global mouse. Oh, so this is it. Position equal. What? So we get the global mouse position. Wait, so this is it? I feel like I've been um dagger. I'm joking you with with a dagger. Was that sweet? Dagger. No. Dagger is. That feels kind of threatening. I end floating ever again. That feels so dark. So wait, it was saying that I should use global mouse position. minus what? That's it? Oh wait, I'm stupid. Oh, I was doing a minus. Oh, was I? Oh yeah, I'm kind of. Wait, I don't know actually. Gets global mouse position. Can I do this? Or do I have to? So I mean, this is to self, right? So I can just do this, I guess? And that should be fine. I don't remember what I did earlier, but I feel like, yeah, I did just bad things. I was just so bad. So yeah, right now it's kind of working, right? But the problem is that I'm using accelerations. So it's not strong enough. It's not strong at all. And I want to update it. Oh, right, I forgot something essential. Maybe. For all of them, we have the gravity. So let's just keep the gravity like it was. And let's put the velocity as velocity, maybe. Maybe. Yeah. I feel like that's gonna be wrong, but key velocities. Let me think a little. Because basically right now we are overriding the velocity, we are resetting the velocity, so we are removing the velocity that the acceleration has been adding like the previous frames. But we want to keep the acceleration. We want to keep the acceleration, but at the same time we want to set the velocity. So this is kind of troublesome, right? So let me just remember what I wanted to do. I guess we have to divide, maybe? Like we have to take the derivative or something. Key velocities divided by delta? Wait, so what if I do this divided by delta, maybe? Is this gonna work? Okay, this is kind of working, I feel like. This is weird. Okay, wait. No, they're not settling. They're just moving so fast. Okay. Wait. We have an equilibrium. Wait, this is good. They're just moving too fast up. They're just moving up too fast. We have to counter that. How can I counter that? I don't know. Sorry. Velocity. Wait. Wait. Okay, I really have to think this time. I feel like the answer is like so stupid, but this is fine. You know what? For now, let's just remove the gravity from the equation. Let's just remove this from the equation. Let's just do an equal. Let's just have an equal for now. So we have this. Then we can drag. And this is just following, right? This is trying to follow. Right, so this is kind of what I wanted. Okay. And if I try to take this one out, it's trying to come back because it's like attracted to the other ones too. So we're basically having like some kind of chain. Okay, what am I gonna do with this? I think we have to compute the area. So we have to use the separating axis theorem, maybe, like the algorithm. So I have to project on like the x-axis, axis, maybe something. Yeah, that's not actually the S80. But this is similar. Okay, let's think with graphs, okay? Let's use paint this time. So let's say we have this. We have... What do we have? We have a few dots, okay? Like this, maybe. A few keys, a few vertices. Oh yeah, a vertex. That's how it's called. I forgot. So then we have a polygon, a concave polygon. Then we have an axis, right? This is an axis. Now we can... Okay, so it's 3 per 3. We have to compute triangles? But triangles are not going to fit it. Oh, wait. I have to get the area of that. And then when I turn and go back, I'm going to remove the one that is below. So that should be fine. So I have to compute the area of this. I have to compute the area from this. So I'm gonna do I plus 1, well, the position of I plus 1 minus the one from this. So I have the, wait. Oh no, it shouldn't be relative. Should it? Should it? Let me think. Yeah, what should it be relative to? To some random axis? Do I have to project, maybe? I'm not sure about the algorithm. I'm just doing that from my from the top of my head right now. I mean, I know that the algorithm is correct, but I have to find out what to compare it with. I mean, I guess this is basically a primitive, right? This is how you compute a primitive. So let's say you have a curve. Well, an integral, I guess. Let's say you have a curve. You have the graph. You want to compute the integral between this point, well, let's say this point and this point. Then you basically compute the area, right? When you compute the integral, you compute the area between the 2 points. But when you go there, it's negative, so it's removing. It's kind of what I want, right? So let's go with, let's go, I don't know. I have to get, okay, so it's in global coordinates. I guess that's fine if we keep the global coordinates. I guess it's just 1. Wait. So then how do I compute the area? I have this. Minus, okay, so this is just y. Y times the other y. Oh, I have to divide by 2 at the, wait. Oh, the area of 1 minus the area of the, oh, so it's like the average of the 2 areas. Oh, I get it. Oh, that's simple. Should be simple. So let's have a compute area, maybe? We have, let's say this. So we're basically going to get j, I guess, minus, well, global position. So we said we had to compute the area for this one relative to 0. So this is not squared, this is, well, actually, yeah, this is length squared, right? Because it's like the dot product with itself. So x times x plus y times y, so, oh, wait, squared. Yeah, this is it. This is the area 1. Then we have the second area, which is the one from I this time. And now we do diff area, which is the difference between the 2 areas. And we return. This is simple. This is like very, very simple. And now what we do is compute full area, right? So we want to compute the area of the polygon. And this is going to return a float. We're just going to loop like this. Boom. All path should return. Okay. So area. I'm gonna compute. So this is I and I plus 1 minus 1. Area plus equal, and when it goes back, it's going to remove the area. So if we look at the graph again, instead of this, we're gonna have, let's go back. Oh, instead of, wait, instead of this, we're gonna have do this, we're gonna have the big area. Wait. Big area minus... Oh wait, I have to take the average, right? And then we're gonna do this. Wait, so I have to do a minus, right? Yeah, I have to do a minus somewhere. Hmm. Hmm. Oh wait, I have to do the minus in x only, maybe? Minus in x, y can stay the same, should stay the same. So let's have a delta 1. That's not going to be a delta, but let's have it anyways. Well, x1. Okay. x1, x2. Wait. p1, p2. This is going to be better. This is going to be vector 2. Actually... Okay, so if in... Okay, we can simplify things, I guess. We can simplify things because if in x it's 0, then... Yeah, let's just keep 0 for now. So let's say we have 0 and we have... this... y. Then we have this, but this time it's going to be... It's going to be this dot x minus this dot y. Oh, dot x, I mean. So this is I dot. Something like this. So you can see. Now I have... So I should still do the same. I should do P1 and P2. And then I average. I take the average. No, not the average. Wait, that's not... Wait, what? Wait, what? Wait. Wait. Let me go back. What am I even doing? So I have... Let's say... Wait. This. This. And then I have the bigger rectangle there. Like this. I shouldn't have this thing. I should remove this. You know what? Let's open something incredible. Well, I mean, I can just... I mean, this is half, so I guess I have to make computations a bit different. Yeah, okay, I guess it's just a minus. Wait. Let me just check at the video again. Procedural. Not procedural. Well, actually, frog soft. Wait. Oh yeah. Okay. So here we go. We have stuff. It's falling. Okay, great. So then we have constraints. Okay. I mean, I guess he's starting with like gravity. Maybe I should like do some gravity too, but I made the constraint. Let's have the valid integration. So, oh right. Oh, I guess there's this. I mean, that's fine. That's not really what I'm searching for. Then there's the trapezoid formula. So this is what I was thinking about. You have this. You have the area. So you have wx2. Yeah, so you remove this. And you have the L, which is the average. Oh, so the middle point in y. And then you have A, which is W times. So this is the area. Oh, right. Yeah, okay. Wait, what? Is that it? Yeah, that makes sense, actually. Yeah, that makes sense. Wait. Was I just remaking this? I was just remaking the area of the... Yeah, I mean, yeah, that's what I was doing. So we have the x minus x. I actually came back to this. And then you have y1 plus y2. And this is divided by 2. So let's have what? That's plus that, I guess. Divided by 2. And this is, we're basically going to get the... Wait. To time it, because it's like the area for a square, right? So let's call it, I don't know, A. And let's return A dot square. No, never mind. A dot x times A dot y, and that's why we keep the sign, right? Because yeah, the square just made me a bit confused, I guess. Because it wasn't keeping the sign, it wasn't keeping the negative sign. So I wouldn't be able to remove it afterwards. To remove the area I wanted to remove. So then we have this, we return the area. And I want to check if this is correct. So let's print compute polygon area. And let's start again. So the area is not showing, actually. It's just not showing. What? Wait, why? Why is it not showing? Chain. Physics process. Print. Compute. Area. So this is 0, but it should at least compute 0, right? Or is it because I restarted? No. Wait, it's not showing anything. That's crazy. Is it even getting... Well, I mean, yeah, this is getting cold because the position is like set, right? Okay, what if I do this? What if I go inside? I do stuff. 0. Oh, I'm not computing the last one though. Oh, so this is a lot. But it's still not showing. Oh, wait. Print? Wait, is this... Consider using push error or push warning. Yeah, that should be on the console. Oh wait, maybe I disabled the things that were not errors. Oh, okay, that's it. Okay, I get it. So yeah, this is it. And then I can just do the same, but from this -1 to 0. Here it is. Here we go. So we go, wait, this is negative. Wait, I have to do the minus actually, right? No, I don't. Do I? Wait. What? Wait, what? What? W times L. I'm doing things right. Interesting. Yeah. That should not be the problem, but let's just keep it like this. Let's continue, maybe? Maybe I missed something. So let's put some
with vertical
sound.
lines. This creates a trapezoid, and we
Trapezoid.
can find the area of this trapezoid by subtracting the x-coordinates to get the width, and then average the two y-coordinates to get the average length. We multiply width by length, and that's the area of the trapezoid. We'll keep going through each point, forming new trapezoids, and adding the area to the total.
Add that to the total.
You may have noticed that we have also been including the area outside of our shape, and here's how we fix that. Whenever the x-coordinate of the next point is smaller than the current point,
when
we'll
it is
actually
smaller,
get a negative value for
we'll get a negative value.
And as a result, we'll subtract the area of this trapezoid.
Yeah, we don't have to do anything
cuts
basically.
Out the extra area that we added before.
Yep, I know that. So yeah, this is basically the area, but
full area of our shape. You could see that we have covered the full area of our.
Yeah, the problem is that it's negative, so I guess it's possible to have a negative area. But yeah, it's getting smaller. Got it. It should be fine. I guess I just have to take the positive area, right? That should be good. Yeah, the positive area is good. Guess I have this. Yeah, so the problem right now is that there's no repulsion. So what I'm saying by this is that I'm checking if like the distance is like higher than the maximum one. So let's try to do this. Let's try to do this. And okay, now we have something a bit more shiny, I guess. We just don't have the area, but the last point is not, you know, getting at the same place as the other ones. It's like trying to get away. So this is kind of, I guess, what we want for now. I do want to fix that in the future, let's say, but this is alright. And now I want basically the two circles in the middle to be split away. I want to conserve the area, and this is because I want to conserve the area that I'm computing the area, if that makes sense. So let's just continue a little bit more here.
Our shape.
So we have the
blob. We'll subtract it
the wanted
from the desired
area,
and then multiply
the desired.
by the scaling coefficient.
We multiply by the current, and we multiply by the scale.
The area and the scaling coefficient are arbitrary values that we can configure later.
What?
And after computing the area of the blob, we'll subtract it from the desired area and then multiply by the scaling coefficient.
Okay.
Both the desired area and the scaling coefficient are arbitrary values that we can configure later. Anyways, this equation gives us our scaling. So
we have the desired and the current one. We take the minus. So this is basically what I'm doing with the position right now. The only difference is that we have the scale. I have that too actually for the position. It's like basically going to be the speed
we will scale
of going back
with this factor by first looping through them in a clockwise direction. For each point, if we take the 2 points on either side and subtract them from each other, we'll get a vector that represents a secant line on the blob. We can rotate this vector by 90 degrees counterclockwise to get a normal line.
Wait.
We'll perform
what?
our arbitrary
So you
scaling
jump
factor.
over.
We will scale our points with this factor by first looping through them in a clockwise direction. For each point, if we take the 2 points on either side and subtract them from each other, we'll get a vector that represents a secant line on the blob. We can rotate this vector by 90 degrees counterclockwise to get a normal line.
Yeah.
We'll perform this
and you add it to this, right? To this point.
Coordinate, and then swapping the x and y coordinates. Now we can normalize this vector, multiply it by our scaling factor, and add it to the point.
Yeah, okay, I added to this one. That's what I thought. Yeah, that's what I thought. Okay. I just didn't know why it was just there. I didn't know why it was there. It was just kind of weird. Yeah, that's what I thought. Okay. Okay. So let's do this. Let's say this time though we are going to have. We're gonna set the velocity, I guess. We're gonna update the keys velocities. So we are going 3 per 3. So I guess we can have a +2 but a modulo, maybe. Well, I guess we can keep things like that. We just need a modulo afterwards. So we have I. That, well, key velocity is I. Plus equal. So what did we have? We have the segment. Actually, this is this +1. So we have, this is like with the modulo. Yeah, let's have I, j, and k maybe. So j is going to be I + 1 modulo. So we go back around. So we have a loop basically. Then we have k, which is the same. K, which is +2 this time. I, j, and k, which are integrals. I guess this one is an integer too. And the goal is to add to j, so the one in the middle, the point in the middle. We want to add the normal times something. So we have the normal times something, right? Something. Let's say nothing. Wait. Let's say maybe force or, F. Then we have. So we have to get k minus a. So this is gonna be keys k dot global position minus keys I minus global position. So now we get the normal. So minus y and x. Normal. Can I have that? No, I can't. So let's say this is delta. You can just get this. Now we're gonna get the normal. So n equals. So this is a vector 2. This is a vector 2. I guess we want to normalize ideally, but that's fine. Let's just have vector 2 delta dot y, so this is minus, and delta dot x, and we are going to normalize that. And the thing with this is, wait, what's that? Delta, oh, it's already been declared. Yeah, let's just have it be d maybe. And the thing with that, like the normal, we can actually just change the sign like this, but then it's gonna be the opposite, right? Because what it's gonna be inside. Well, actually, it depends on. Yeah, actually, it has like we can basically get 2 normals, and it depends on how we set things up at the beginning. So we might have to multiply if this is not the correct one, but this should be fine. So let's keep it like that. Let's keep it like that. It depends whether it's like um, clockwise or counterclockwise. So we have N, and then we have F, and F is supposed to be the desired area minus the current area, let's say, times a scalar, right? Because it's like the force, right? It's the force. So I'm actually wondering if I should use the delta, but let's keep things like this maybe. Area. Yeah, let's. I actually don't know. Let's just put something like 10. I don't know. Okay. How is he cutting this?
For the point. In fact, this
Dilation
for the to get wide. And
well. Area speed, let's say. I'm not sure if this is it, but let's say this is it. That might be a bit too much. But anyway. So we had something like a lot. We had a lot, okay. Like 60,000. 60,000. Then we have current area, which is something we can compute, which is just this. Current area equal this. So this is a variable. Here we go. I can print it here, I guess. But yeah, if the area is negative, then I'm afraid the normal is going to be the opposite too, basically. Area speed is not declared. Yep. This. That should be fine. Okay, let's try. Let's see what we have. We don't have anything. We have none. Oh. Oh. So yeah, maybe we need a negative. Maybe not. Maybe not. Yeah, because normalize is going to be between 0 and 1 anyways. Oh, so I guess it doesn't... Wait. Oh, no, it's not going to be between 0 and 1 because it's dividing. Yeah. It's dividing by the square, but we have this on top still. So... Wait. Maybe I should make sure things are... Wait, this is clockwise. So J... Oh, I don't have the... No, I do have the modulo. Okay. Deny. Okay. Yeah, something is not good. Or maybe it's like equal, actually. Oh, right. Oh, yeah, this is it. My bad. Yeah, my bad. My bad, my bad. My bad. Wait, plus equal. Should I reset the velocities? Wait, I reset them here. Huh. So yeah, should be good. 10 might be too much. Oh. Okay, this is kind of working now. Look at this. Well, maybe not. But yeah, look at this. This is kind of working. And when I turn, this is kind of being weird, but in the end, we have what we want, right? Kind of. Why is it so weird? What the Oh, it's when I'm changing. It feels like the particles are dephasing or something. I don't know what's going on. Okay. I kinda wanna generate a circle now. So prefab, it's a packed scene. And instead of having the keys directly, we're gonna have a circle. So let's create a circle. In the ready, we're gonna have, I mean, yeah, I guess we can just generate it directly. So NB points for I in range, NB points, well, NB keys maybe. Let's have something there, like 10 maybe. We have, we have the radius, which is 100 or like 200. The flat. And then for each key, we're going to push back. We're going to instantiate there. So point, let's say. Like key, I guess. We push back, and before that, we set the position to be, maybe just position actually. Position is fine, not global position. This is going to be the cos of, so I is going to be relative to the angle. This is in radians, so this is like 2 pi. Do I have a variable for that? Usually in engines there are like tau. Oh yeah, this is tau. Circle constant. So tau divided by I. No, not I, NB keys times I. So this is going to be x. And then we are going to have the sinus, which is y, which is just going to be the same. So we can make a variable angle, which is this. And here we go. And then we multiply by the radius, right? We have to use it somehow. Okay, should be good. So now we have the keys that are set up. We can remove this, I guess. I mean, let's, you know what, let's just clear, maybe. Well, yeah, this is fine. Let's keep it like that. Hello, how are you? Ruipana. Ruipana, how are you? How are you doing? Instant shit, yeah, it's now. Oh, everything's now. Key. I'm good, but I think I'm, sick again. Oh. Well, take care of you, of yourself. And yeah, just, chill with me, I guess. Let's remove the physics process. So, yes, great. So yeah, if you want me to tell you what I'm doing, basically I'm trying to make something that doesn't work, obviously. Uh, wait, what even is this? Not 2D. Oh, that's the ground, right? Wait, that's... What is key? Key is working. I'm trying to make a circle for now. I want a circle. But... Oh, I have to add it as a child as... Okay, yeah, I have to add it as a child. So... Instantiate. Add the child. Key, okay, should be good. OMG, hi, Ruipana. Oh, we have a circle, incredible. I'm gonna look and play video games. Oh, I will not understand. I mean, it's just a circle for now. You can understand very easily, like visually. Game engine stuff is often beyond me. That's fine. I got cued into game. Okay. Hello. Okay, so we have these little things. So now let's try to make things great. Please work. Okay, it's not working. Okay, what if we remove the area? So this. But you're great. Who are you talking to? Wait, this moving apart. Wait. I guess I have to shake my head. Oh yeah, Ripana. Yeah. I mean I mean I don't really know her, I guess. Her? Him? Her? Him? I don't know. Oh. I know Ripana. I like pronouncing it like with the, well, rolling the R for some reason. Like ravioli. But I don't actually know. Oh, okay. But yeah, I figured out that you knew Ripana. Ripana. That sounds very kind of. I was gonna say Spanish, but I don't know that word in Spanish. Maybe like what? What's the other Portuguese? That's like similar. I guess you have. So you also have. The language from the Philippines. I mean, there's Tagalog, but Tagalog is like not at all like this, right? So maybe if I just pick a variation. Anyway, um, let's maybe increase. So we have the move and slide, right? There's something wrong with this. Let's divide by the delta, maybe. And let's see how it goes. It's going to go very bad. I knew it. I knew it. Okay. So we have stuff. Somehow we have stuff. We have circles. And when I drag away, it's trying to go back to me. So I guess I have to multiply this somehow. Oh yeah, because this is... Oh yeah, okay, this is a lot better, right? Well, now it's not keeping the area, but this is basically what I want. Well, I wanted to keep the area. But yeah, you get me. Now it's getting like a lot... Maybe a bit too fast, actually. Yeah, 10 might be good. 10 is kind of fine, as you can see. Now I just have to keep the area. So I'm doing... Oh, wait, I'm doing a plus equal 2 times. Wait, what? Was I doing that before? Wait, I was doing that before? Wait, that's kind of... stupid of me. Yeah, that's so stupid of me. Okay, here we go. Let's just update the area. And this is still stupid of me. Okay, something is wrong. Area speed might be too fast again. Desired current. Oh, wait, I have to get the absolute one, right? The absolute area. I guess that might be why. Never mind. Let me check this again.
Subtract them from each other. We'll get a vector that represents y.
We get the vector, we get the normal.
Scaling factor, and add it to the point.
Add it to the point.
The desired location for the point.
Okay, so
and note that we'll be averaging this dilation effect with all other distance constraints on the point.
For all other distance constraints on the thing, on the point, right? So you average by just adding together. Wait, you average? Oh, you average, so maybe you divide by 3. Or maybe you divide by... Wait, what? Wait, what? Wait, you do that for each point?
If we can normalize this vector, multiply it by our scaling factor, and add it to the point.
Yeah, that's what I'm doing.
The desired location for the point.
Yep.
And note that we'll be averaging this dilation effect with all other distance constraints on the point. If we repeat this process for all other points
that should be good.
We'll have successfully completed the dilation algorithm.
Yeah.
Running the simulation again, the blob looks much...
Yeah, it should be like this. This should be a lot better. It shouldn't be like me. What's wrong with me? I don't know. Key velocities. Oh, is it because oh, wait. I'm not clearing anymore. Maybe I should clear. Maybe I should just reset everything to 0. That's not helping. Okay. Key velocities plus equal. Wait. Mouse. Wait, I still have this? Okay, let's remove it. I have some garbage in my code for some reason. Okay. What if I put a breakpoint at the beginning and check if there is a velocity or not? Boom. Okay, is it getting reset? Key velocity is 0. Great. Resize. So now we have a lot of zeros. Great. Oh, I do have it at the end actually. Never mind. So this should be good. Yeah, I have something wrong somewhere. I don't know where. I don't really like the move and slide. I mean, maybe I should just... Wait, dot velocity equals 10 times... Why was I doing that again? To make things faster, right? Yeah, and it's... I mean, okay, that's fine. Global position. Maybe I shouldn't do this. It's still getting away like crazy. Let's check maybe added velocity. Let's try to print this because there's obviously something wrong here. Normally, so n should be right. Well, or maybe it's opposite. It's opposite. This. Added velocity is crazy though. What did it start with? With this? Wait, that's crazy. Area speed. What even is that? It's like 0, 1. Wait, what? Oh, wait, that's the area, right? Wait, what? Oh, yeah, so maybe it's just like too much, like really too much. Maybe something like this is better. Okay. Okay, 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 okay. Okay, okay, I have an idea. So this is a bit better, right? But I guess I have to get the absolute value. No, never mind. No, because I want to multiply the normal in the right direction. Right? But I guess... What if I do this? Oh wait, it's doing things. I don't understand what it's doing, but it looks better. Well, it doesn't look like anything though. Yeah. You know what? Wait. Yeah, absolute. Okay. Let's go back to the video.
It's more like we could add the velocity to the position and the acceleration to the velocity.
Yeah, so basically he's doing the movement himself. So he's... Yeah, basically I'm using this, right? So this is a bit like different. It has to do with the position and the velocity. I think that's the problem because other than that I'm doing like kind of the same computations. So... so what? Move and slide. Because I know that there is something else. Slide along the other body. I mean, I guess I can keep this. So after that, he's modifying into Verlet integration, as you can see there, which is a better way to approximate integration for acceleration, velocity, and position. Well, for position, basically. Um, well, a more stable way to represent it. So if you just do position plus equal velocity times delta, there's going to be some instability, let's say. xt plus vt plus at. What?
Fine, which makes sense. And that also...
Yeah, anyway. So I was saying,
should be
this should be 2 times x minus the previous x plus the acceleration at the time. So we are removing the velocity from the equation, basically. Well, actually... Wait, what?
compute. This is without any velocity term at all by substituting this new formula for velocity.
Substitute. A.
And this is actually called Verlet integration. Also, since we're using positions to compute velocity, the change in position caused by our distance constraints should be...
Wait, what?
Position caused by our distance constraints should be incorporated into the physics system now.
Yeah. Yeah, that's kind of the problem.
Perfect. Now,
so basically my problem is we are setting positions, but if we set positions, we can't have collisions the right way in Godot, because to detect collisions in a correct way, you need velocity, because it's using the delta to move. So it's not gonna be great. Collisions are not gonna be great. And that's basically how you can go through objects if you move fast. So that's why you shouldn't really... I'm gonna look. Okay, see you. Let's what? Let's go back.
That our distance, a constant area incorporated into the...
So position. For each one we have key global position equal wait, what? Wait, what? Wait. Oh, so you have to keep the position between two frames.
Velocity called Verlet integration.
Wait, what?
Change in position slightly better. First, we can swap the velocity term in the position function to use the updated velocity term instead.
Wait, what? VT plus 1,
this
okay.
Is called the semi-implicit.
So you compute VT first.
Before. It also allows us to simplify our equations.
Wait, what? Wait.
But we're not done.
So this is the previous VT plus the acceleration.
Done here. Let's take a closer look at our position function. If we rearrange the terms, we find that the velocity is equal to the change in position over time, which makes sense.
Yeah.
And that also means we can rewrite our function without any velocity term at all by substituting this new formula for velocity.
Substitute the new formula for velocity.
And this is actually called Verlet integration.
Okay, so we don't need the velocity, right? So... yeah, wait, the xt minus 1, he's just... okay, from the previous one. Wait, so this is... just the previous velocity, right? But I guess, yeah, we're not using this. So we have to keep the previous position. Okay. And we have the acceleration. So the acceleration is gonna be the... I mean, I guess that solves my problem about the gravity, right? So you have gravity acceleration. So let's say this times delta times delta, I guess. Is it? Yeah, that's not an equal. Wait, what is this saying? Oh, this is a delta, right? Wait, what is even... because the acceleration is not... wait. What? What? Times delta, I guess? He's not talking about deltas, but...
this is actually... let's first position function determine...
because he's basically just not talking about the delta and a lot of stuff.
Position function.
He's just...
we can create more complex and incorporate...
wait, so... global position equal the previous global position times 2. So we can try to get this times 2 minus the previous one. So the previous one, I guess we need a variable for that. So previous global position. Is it 0? I don't think it should be. I mean, okay. We could have this. Well, global position. And then I guess we have to save it somewhere. So like here, probably. Global position equal the current global position. That doesn't feel right. Oh yeah, this is Wait, this is so strange.
Incorporated into the physics as assigning it when our work.
I guess that's it.
Should incorporated in.
Because even like I remember the valid integration, but I don't think there was. I mean, I think you still had the velocity. I don't remember a version without the velocity. Maybe I'm just not getting it. Yeah, he's still computing the velocity, right? And then calculate the next velocity. Yeah, it's just his version, that's just kind of weird. I mean, okay, I get it, you replace it so you don't have to compute the velocity. But, okay. Yeah, I just have to remember to... Let's get to temp. And... yeah, let's just call it current global position. Now let's assign it. So we don't, we override the current one. Wait, actually, that should be, oh, this is for each point. This is for each point. I forgot about this. I mean, I can move it in. This dot resize at the end, I guess. Keys dot size. Here we go. So now I should have I equals this, right? So I should keep like the -1 basically. And now I can use this, probably minus this, and I should have the plus acceleration. But like, is there a delta time? That's my question basically. I feel like there should be a delta time. Like, there's no way there's no delta time. I feel like he's wrong. It feels really unintuitive, because if we just add the acceleration, it's just gonna accumulate, right? And it's just gonna be something really weird. So it should be like times delta. I think it's gonna go bonkers right now. Yeah. So let's try go back to the line. Times delta maybe? So that we get the position thing. Oh. Let's put this. L, please. Okay, good. Not good. I feel like it's maybe a bit better, but not good. Current global position. Let's just remove everything for now. Even this. It's still moving like crazy. Current global. Yeah, because this is not working. This is not the correct formula. I don't know how to do this. Like, I don't know what he's doing, but yeah. Let me check. Learn about constraints. Oh, wait. This is from the description. Yeah, this is a constraint, okay. This is fine, this is what I had. Distance constraints chain. Yeah, this is what I have, but I have the loop. Right? I have the loop. Like, this is exactly what I had with the mouse. Fabric chain, so this is for IK animations. Well, actually, wait, this is not, well, no, this is, well. Oh, so that's how it works. Okay. Anyway, um, okay. Yeah, I mean, I guess I have it. I mean, I guess I'm just keeping the, well, I don't have the first one there locked. Distance constraints can be used to separate. Collision constraints using violet. Okay, show code. Violet rope. Okay, so here we go. We have the current position. What is ball? Wait, what is ball? I guess this is a position. Yeah, this is the position. So position of the current one minus the previous position. What? No. What? Plus equal. Oh, so yeah, this is like 2 times bullseye minus prev bullseye. Then I update the previous position, and there's no acceleration. The acceleration is like, where is it? Where's the acceleration? Oh, wait, it's there. Exact gravity. By translating downwards 1 pixel each frame. So yeah, it's each frame. There should be like a times delta or something. I have to set the current, well, the previous position. Am I doing this? 2 times the current one. Then I'm getting the previous one. Yeah, that should be good. And then I'm doing the plus. This is like exactly what I'm doing, right? If we look at this, I think I'm correct with this one. For each key, for each ball, I get the current one. I get the current one. I have my variable too. I'm setting the velocity though. Well, I mean, I'm not using the velocity, right? So it doesn't really matter. Then I do, instead of plus equal, I do the equal 2 times global position minus the previous position. And then I set the previous position to the current one. And you know, the plus equal one, I'm just trying to add it with the acceleration of the gravity. Wait, it's actually so big. Why is it so big? a frame. I mean, it shouldn't change anything. I don't know. Is it because of the... Oh, no. Delta, this is the physics delta, right? Accumulated delta may diverge from real-world seconds. Each physics tick. Delta is the logical time between physics ticks. In seconds. Okay, this is good. This is good. And yeah, it just doesn't want to work. Even though I just have the... I don't even have a process, right? Basically, if I do this, it's just not moving at all. Right? Yeah. So now I have... That's crazy. So yeah, this is valid. Collision constraint, okay, I have something. I don't really care about this. I just care about the Verlet. Let's go there. Verlet rope. I guess it's just really fast, though. The gravity is like so fast. Gauss-Seidel method. Converge is faster, but technically not correct. Okay. Volume preserving soft body. So this is the thing I want, basically. This is what I want. This is my goal. That was my goal all along. It was a soft body. I wanted to make a soft body. Can I actually... Is there something like that in Godot? Using soft body 3D. What about 2D? There is something like that. Oh, but it's an asset. Oh. We have a plugin though. Okay. That looks maybe... I don't know how it looks like. I mean, I guess I might use it if... Well, after finishing this. I at least wanna have this right. It's like 1 AM. So wait, what's the code? Jacobi method is useful for keeping phantom forces from appearing. So this is basically the code. This is the code. So on frame, what am I doing? Let's integrate. At the beginning of the frame. Well, I mean, I only have that in my frame. So temp, I get the current one. Blob and blob old. And then I do the plus equal. Oh, delta. So we have the delta there. Wait, this is the minimum. Oh, right. I guess that makes sense. Let's remove the gravity for now. Circle.position equals view.center. Okay, this is a black thing. This is fine. So let's just try this. Let's just have violet, let's say. And for every little circle there, I have, sorry, so let me check again. On frame, violet integrate, I have the temp, so this is current global position, equal global position, so a copy of, yeah, this is taking a copy, right? Of the current point. This is taking a copy, right? Duplicate. Wait, maybe, wait, that's Godot vector 2, copy or reference. This is a copy, right? Not a reference type, this is a value type. Great, this is good. So yeah, I'm having a copy. Then I'm setting the current one, so global position I equal, well, plus equal, I guess. The current minus the previous. So this is like a plus equal current minus previous. And I guess we can remove the gravity for now. And next frame, we have, well, next frame. Yeah, we set the previous one to the temp one. So this is what I'm doing. And I'm just calling this, basically. Without any delta time, without anything else. And points shouldn't move. They are moving. So this is a problem with my initialization. This is a problem with ready, push back. Wait, where am I setting previous? Oh, wait. I'm resizing, but I'm never setting it. Yeah, okay, of course it's not going to work then. Okay, my bad. Let's reserve the keys too. So it's like optimize. I mean resize, I guess. This is fine. This is better to resize because vectors basically have 3 pointers: the begin, the end, and the reserved size. So we don't want to move the reserved size too much. Well, when we push back, we increase the reserved size. No, not the reserved size. The reserved size is set by both resize and reserve, but the end pointer is moved, well, pushed back when we push back. So we want to prevent that. This is not a lot, but this is a little. So we have the keys. We have previous global position I equal key, and now it should be a lot better. Okay, that should be why it was not working. Wait, that's still not working. Key global position. Wait, what? Keys? Oh, right. Yeah, okay. Yeah, okay, makes sense. Wait. Oh, wait. I prefer adding it as a child here. Maybe I don't know. Maybe I don't. Yeah, let's just do that. Okay, so this is good now. Okay, this is good now. Perfect. So that means I can remove this. I can put it. I mean, let's keep it at the beginning, I guess. Let's keep it here. Let's just have some gravity, should we? So, gonna loop gravity for each position. Wait, current position. I'm adding the gravity acceleration times delta, or just times delta one time, maybe. Let me check again. Which one was it? Here. So we have that. This is times delta only one time, but we have it times 30. So... so what? Because I guess one frame is supposed to be 30 seconds, like around 30 seconds. So I guess it's trying to emulate fixed delta time. So maybe just the delta is fine. Well, not delta, just adding the gravity, so 1. Yeah, because this is the minimum, right? So I guess adding just 1 is fine. Well, 1, the gravity, right? Yeah, just adding the gravity is fine. That feels so wrong, though. That feels really wrong. But I mean, it's a fixed delta, right? So I mean, it should be fine. It should be fine. Well, no, maybe it's not a fixed delta. It's a fixed process. Okay, let's say it's fine. So let's try the gravity this time. Okay, so the gravity is working. Okay. So we have it. This is gonna be great. We update this thing, whatever it is. Wait, what is it doing? It's updating the global position, right? Accumulated displacement. So yeah, this is what I call the velocity. But I guess you want to set it at the end so that... Okay, so you reset. That's what I wanted you to. But there, you apply. But you divide by the accumulated displacements. So yeah, it's a bit different from what I was doing. It tries 10 times to resolve the constraint. So wait, what is this one about? Is this about the... I think this is about moving the normal thing, right? Then we calculate the area of the... Wait, of the black bulb. Yeah. Is it less than... Okay. Wait. Deviation distance. Oh. Oh, right. Oh, that's what I had wrong too. I had that wrong too. Yeah, I had so many things wrong. So I mean, I knew that I had to iterate multiple times to resolve the constraints because I mean it's physics, right? You want to resolve constraints. But let me just check this. Put the segments towards each other. So yeah, this is basically what I have, and I was plus. So for each point, wait, offset. Oh wait. Oh wait, I was computing the constraint multiple times, but I guess I only have to compute it one time. Yeah. Yeah, I can only... It's fine if I compute it only one time. So instead of computing... Which one was it? Update segment? I don't have to do the update segment. Well, this is basically what I was kind of doing, but I was doing it 2 times, right? I was trying to do it here too. Which wasn't, really what was required. So let's just keep this. So it's looping 10 times, okay. So segment next, and then the... Wait, what? Next index, next segment. Wait, segment? Oh. Point to the next. What about the previous one? What is I? I times 3? Oh, because you have... Wait, what? Oh, wait, this is... Oh... XYZ, right? Is it? What? Wait. No. Wait, no, so this is what I had. I accumulated. I mean, I could just copy, right? But I kind of wanna understand. That's kind of the goal. Because I've been wanting to learn about soft body for a while now, because this is like really used. This is very practical. This has a very practical use that anyone, well, you know, with a bit of experience in gaming could, well, can see. So, yeah. So, points. So points is the amount of points. This is not an array. And then you have segments. And segments is the actual points. What? Oh, this is like in WPF. Segment is actually a key. It's actually a point. It's actually a vertex. Segment, next index, so we get the next point. So we have the current and the next, and then we do stuff. We have the offset. Wait, the offset? Minus 2 next. What is 2 next? Point minus next segment. So wait, this is going from the... This is going to be from the next to the current segment. This is wrong. Right? Yeah, this is wrong. This is the opposite. That's why it's doing minus. Probably. It could do a plus. It's checking the length. If this is higher than its setting. Wait, you can do that? Wait, you can do that? What? What? So X, Y, and yeah, I guess Z is Z. Why is it... What is it using accumulated thing for? Accumulated displacements. So we have X, we have Y, and we have divided. So this is the amount. Okay, so this is trying to get the average from that. Drink. Okay. Thanks. So... Yeah, I mean, I get it now. I get it. Okay, I guess we can do something. Offset. Okay. Yeah, so, well, when he was saying like the average in the video, that was like the real average. Got it. That's why it's like always better to see in the code itself. Compute area, update segment. I guess it's like the compute segment, so I want this basically. I'm gonna remove this actually now. I'm gonna have... Well, actually, it's just going to do a +1 every time. So it's just divided by 3. I actually know already. Oh no, because it depends if it's like higher or not. Oh, okay, interesting. Oh, right, because then we push... Got it. So let's say we clear, we resize, so we basically set everything to 0. This is not optimized, but this is fine. We try to update segments. How is it calling this? Well, displacements, but he has another word for constraints. Yeah, this is resolving constraints. So resolve segment constraints, let's say. So we have this. Oh, so I did have this before, the max distance. If previous dist is bigger than max dist, yeah, it did have the same. So wait, it was there. If it's higher than the length, then I normalize. So this is basically what my formula was for. Distance 2. Yeah, I mean, okay, I'm doing a minus, but that's fine. And the direction can be computed there. So I have the direction. Offset. So in both cases, I have the offset, which is minus equal this divided by 2. Wait, it's 2 next. There. Whoa! I just realized that's crazy. He's doing crazy stuff. It's like JavaScript. Okay, that's kind of crazy JavaScript. Anyway, so we have the direction. We multiply wait. Let me update the music because there's one I really like. Wait, it's just looping. Can I have intro, I think? Wait, that's intro. I found it. No, I haven't. It's the next one. Never mind. Okay, fine, I'm gonna let things like that. You win. So I have the offset. No, I don't. That's the problem. It's doing something weird by just setting the size. Basically, it's a normalized times. So length is the max length, right? So yeah, this is normalized. The direction. And then yeah, the delta is basically me computing times the length minus the two next. The two next. Well, it's something similar. Um, Wait, what? Wait, what? So direction is from A to B. So it's going in that direction. Yeah, this is fine. This should be fine. We are trying to resolve constraints like this. So we have velocities. This should be good. That should be good. And we just should maybe have a vector 3. Oh, not there. Yeah, this is not really velocity now, but that's... We're gonna cheat a little, okay? So this is plus equal vector 3. This is not good. Yeah, you understand why he had this thing before. I just have velocity equals this. And this is plus equal. So plus equal vector 3, velocity times x, velocity times y, and 1, I guess. And we're just gonna have the same there. Wait, that's the same. Okay, I mean, that's fine. Equal. So here we go, we resolve. Well, we resolve for, well, we don't really resolve actually. We set segment constraint, I guess. Update segment constraints. Well, add constraint. We add the constraint, and we want to resolve like there. So without the blob, before doing the blob, we're just gonna update. So we basically loop through every point, and we check if z is higher than 0. So you know, if like there are constraints, and if there are constraints, then we do stuff. So for everything there, I have keys I.global position. Well, actually, let's go back up. Let's go to... Which one was it? Wait. Key velocities, I guess. If this... dot z is higher than 0, I guess... is nearly equal... Yeah, okay, let's just do this. Should be fine, we just add +1 every time anyways. So let's have this. If this is higher than 0, then I plus equal a vector 2 of this dot x, this dot y, and I divided by this dot z, right? And that should be good. Let's check again. So for everything, we get the point, and we plus equal x, y, and we divide by everything. That should be good. Then we reset, I'm already doing that, and then we handle collisions. I'm not doing that. This is fine. Yeah, it should be good. Alright, I forgot about this. Okay, let's set it to attach to the mouse position. Maybe it's not great, actually. I guess it's like, it has to do with like constraint stuff, I don't know. Plus equal this minus this, maybe? What am I even doing? That's just the same. It's just going to be the same. So yeah, how is he even moving? Well, changing it to circle.position equal. Ensure the black circle stays centered in the view. Okay, this is not what I want, right? Mouse colliding. Am I using that somewhere? Oh, there. Oh, handle. Wait. Alright, there's a collision thing. Point equal distance. So I'm just setting the point. So setting the point should be fine. Setting the point should be fine. What if I do if key, well, input dot key pressed? Let's say we have key J. If we do this, then we set the position. So it's not right now, but it's gonna be there. Okay. So yeah, it's really not liking something. It's really not liking me setting the position. What if I just don't do this? What if I actually remove the gravity and just do this? Yeah, this is not working at all. We're just moving so fast in different directions. Yeah. So this is because of the constraints. I'm doing something wrong with the constraints, am I? I'm not resetting. Wait, actually I'm resetting this to 0, right? So that should be fine. Let's just do this just in case. Yeah. Oh, velocity. Wait, no, never mind. Oh, it's divided by 2. No. Oh, it is. It is divided by 2. I'm not dividing by 2. Let's try that. Because we have to apply the force on both. Okay, this is a bit better. This is not perfect. But this feels a bit better. Okay. Let's bring back the gravity for now. Radius, distance, I don't need this. Set distance. Wait, what's the black blob? So it's doing the same as me, it's like making a circle, generating the circle with an algorithm. I can basically not consider that for now because I need the base algorithm to work, so let's not consider that. Reset the accumulated forces. Calculate area. What am I doing wrong? I don't get it. I really don't want to go to sleep until I fix this. Because like this is so simple. Like there's not a lot of code. Oh, I guess I don't have the 10 iterations actually. I mean that shouldn't be that much of a problem though, but so J. Oh right, wait. Actually, oh yeah, that might be for the best. I don't have the loop. What is the two next? Oh, never mind. Yeah, I remember what it was about. Okay, okay, okay. Let's try this again. Let's try this again. Let's have a J in range 10. Let's try to resolve. What was that? Yeah, okay, this is not good. This is definitely no good. From this to this. Okay. Plus equal. Yeah, never mind. Gravity, okay. Yeah. Yeah. Oh wait, there's a minimum between this and this. Well, I mean, okay, this is fine. So wait, 30 is actually the... Yeah, no, wait. Never mind. Never mind. I think. Yeah, never mind. Iterate 10 times, resolve. Okay. I mean, we can try this again. Because right now, this is like the only problem I have, right? Because my generation is fine. My gravity is fine. Well, my generation, my circle is fine. My gravity is fine. It's working. So maybe I want... Maybe I want to check the collisions instead. Maybe it's just my mouse thing that's the problem. Yeah, let's maybe handle collisions in some way. Point equals set distance. What do you mean? So we have the mouse pulse. We have 40. So yeah, we just set this though. To anchor. This is doing some shenanigans. I don't know. This is doing some stuff. Plus minus. So yeah, it's doing the same as me, but with signs being the opposite. Oh! Oh! Oh, right! This is a plus, but this is a minus here, but not before, because we need the plus one. Oh, okay, okay, okay. I get it. Okay, okay, okay. Please, please, please. Okay, let's maybe enable it. That could be great. And now we can go, and now this is gonna work, and now we're like super strong. Here it is. This is working. Look at this. This is working. So this is kind of bad for now, but this is working. This is working. This is incredible. Desired area. We don't have that for now. Max distance between each point is like 100. Let's say it's 100 now. So it's gonna be something like this. We have everything on the screen, and now the only problem is the area, right? We are not conserving the area. We are not keeping the area. It just became a chain at this point. But this is a lot better. And yeah, and the next goal is to make a sprite out of it, I guess. Ah, okay. Okay, great. This is great. This is really great. You don't understand how great it is. This is amazing. Yeah, that was kind of a stupid mistake of me. What I was missing from the video basically was I didn't take the average, and when I finally tried to take the average, I subtracted the amount. So it was like multiplying by a negative in one case, so it was kind of bad. It was really bad. So here it is. And for this one, I don't think I have to take the average because I'm only doing that to one, but I might be wrong because he did talk about an average to delayed. Wait, so let's check this first. Area, if this is higher than the desired area. Wait. Okay, so if this is less than 2 times the area, what is area? What is area? Radius times pi. Makes sense. So it's desired area minus current area, delta area. So we should have something similar. I guess I don't have to compute the area every time, so I'm just going to put it there instead. Current area. So then we have delta area, which is desired area minus current area, because current area should be less, right? So I guess there's a condition in this. Where was it again? There. Wait. Oh yeah, it can be 0. Yeah, okay, forgot about that. So there's like a minimum. I want to get the minimum, right? So it should be positive though, right? Yeah, it should. This is less than area times 2. Wait. Yeah, there's something wrong, right? Why is it times 2? I don't really understand. I mean, I guess this is fine, right? I guess this is like just some constraint. Oh, drink, okay. Okay. We're gonna have some war. Some little war. Let's hydrate. So, yeah, this is like not needed. It's not something I need. Desired minus the current one is what I need, and then I have to get the maximum between that and 0. This is all I need. So 0.0, I guess. I'm not using it. Yeah, okay, that's fine. So then, for each point, I get the previous one and the next one. I'm doing the same, but with a modulo instead. That's fine. Then I get the normal, which is the next minus the previous. So I mean, well, this is actually just the delta, right? But then you want to normalize it and to, change things around. So angle. It's doing a rotation in degrees. And length of 1. So yeah, it's normalized. This is what I'm doing. Get a normal, then you normals I dot segments. What is this? What is this? Oh wait, it's checking if what is it doing? Normals. Is it using the normals somewhere? Somewhere else? It's not, right? Normals. What? I guess what? Oh, I guess it's like the default normals. What? Is it? Oh, it's for the shape. Maybe. New path. Oh, new path dot line. Oh yeah, so it's setting the normal for the shape. So it's updating the line. It's updating the direction of the line by setting the normal. So I don't need to do that. Probably. I need to do something else though. I need to update the points themselves. I mean, I'm just doing that there. So it should be good. Accumulated displacements plus equal, and yeah, we have the plus 1 too. So we have the plus 1 in any case. Oh wait, we have the division at the end. Yeah, we resolve at the end. So wait, we do the 4 for like everything. Oh, got it. Like even... Okay, yeah, everything, got it. Yeah, even the collisions, makes sense. So we reset the accumulated forces for the next frame. Oh. Okay, yeah, like really everything, okay. Got it. Plus equals that's well times dilation distance. So yeah, this is basically going to be the same thing. Got it. I got the algorithm. I understand now. I really understand what to do. So this is at the end. I want to resolve at the end. Like that. What? Yeah, I don't need this. I have the gravity now. You can't beat me. I have to clear and resize at the end. Well, I mean, it's just resetting the stuff. Let's do this. So this is a resolve constraints, I guess. Well, I mean, move. Yeah, this is just a move. This is fine. What is this? Already J? Oh, right. Let's call it nothing actually. Wait, I can't do that. Oh no. Let's do a Z. I don't know. I really don't know. Okay, I have this. Wait, what was it? I need well, I mean, I guess it's 0, right? If like the delta is 0, so I mean that's fine. There's no if required. So now I have the normal, the n variable. I have the delta area, which is this. I'm just gonna get the absolute thing, probably the absolute area, just in case. You know, we never know. I don't. So we multiply by the delta area, and we have the area speed, so that's fine. Yeah, let's keep it like this for now. And then at the end, we plus equal key velocities. So that was, no, that's a vector 3. So it should be a vector 2. But we are going to create the vector 3 here. X, Y, and this is 1 for Z. And it should be good. Please, please. Maybe I have to increase the velocity. Oh. Oh no. Oh, I have to reset, right? I forgot about this. That's fine. I can set it there. Look at this. This is working so well. This is working so well. And now if I increase the speed a little bit, this is not really a speed, but this is the force, you could say. Okay, maybe this is a bit too much. Yeah, it can't get back. Okay, this is great. This is working. And yeah, there's like the collision too. I just realized. It's always going to go above. Or not, actually. Well, actually, okay. It's gonna... Okay, that's fine. I mean, that's fine. We have our little soft body. This is great. We have... Yeah, this is great. I love that. Okay, now I just want a ground. I just want a ground. Give me a ground. Yeah, I have a wall. I'm supposed to have a wall. I don't really have one. It feels like... What if I put 200, 2000? Let's check if we actually have collision now. We definitely don't. That might be because of because we are setting the collision though. I mean, no, because rigid bodies are colliding between each other, right? Like if you look at this, but actually they're not colliding. Wait, they're not colliding? I guess they're not. Maybe that's just the equation. Yeah, that's probably just the equation, I feel like. Now I'm just having fun. Woo! And throw! Supernova! Okay. But this is, yeah, this is supposed to be a collider. So now I can compute the position, right? What if instead of setting the position directly, I just compute the velocity needed to go there by next frame? Is it gonna work, you think? I kind of wanna try this. So key positions we could have. Key global positions. Like key positions. This is vector 2D. Vector 2. No, I'm too lazy for that. I'm too lazy for that. Am I? Okay, let's try it. Well, let's actually check one thing first. If I have a simple key, and that in my chain I have a reference to fall, well, falling down. Let's say it's a node 2D. Okay. Wait, it's actually a character body 2D. And I'm setting this in ready, or like in process, physics process. This dot velocity equals vector 2, 0 minus 10. And if I look, what is it going to do? Wait, so it did... Wait, 10 is actually maybe too much. What about this? What if I keep it up? Oh, maybe it's not falling actually. Yeah, it's just gonna move very slowly at this rate. Oh wait, because I have to move and slide, never mind. Move and slide. Let's do a... Yeah, 100 is maybe too low, too slow actually. That's the opposite direction. Let's do a 400. Oh wait, boom. Okay, let's try again, but without our little balls colliding. It's just going through, right? It's just going through. So what's the deal with this? Collision. Moving platform. Oh, whoa! Oh! Right, I'm not setting the wall layer. So if I set the wall layer, is it going to... No, it's not. Floor layer. Wait. Oh, because I guess I have to stop? No, it's supposed to slide automatically, right? What is it sliding with, though? Slide over the other body. Or rigid body 2D to also be affected by the motion of the other body. Okay, you can use this to make moving and rotating platforms. Modifies velocity if a slide collision occurred. To get the latest collision, call this. So what if I maybe just set it at the beginning? Something like this. Wait. Like this. I don't understand. Why it's not working? Can I maybe just print print this, because it's supposed to return true, right? When it's hitting something. True if it's colliding. Maybe I have to stop it. No, it's supposed to collide and false. It's always false. Collision, layer 1, mask 1. Godot collisions don't work. Well, more like rigid body 2D and body character 2D collisions don't work, I guess. Fun fail because they are designed to be moved differently. Contact monitor. Nope. Set contacts reported to 1. What? Move and slide or move and collide. This is what I'm doing. Layer mask, I verified that. Animate table body 2D. No, this is not what I want. Integrate forces. This is private. I'm not moving the rigid body 2D. So I mean, debug visible collision shapes. Where do I have this? Wait, 2D input? No. Collision between. Okay, I'll read it. Let's see what we have. Wait, it's Among Us. It's Among Us. Wow. Collision layers are what an object belongs to. For example, set your tables on layer 1. Now, if you have a player with a character body 2D, you'd put the player itself on layer 2. And collision masks are the collisions you want to test for. Yeah, I know. I'm gonna verify that again. But I mean, if two objects are... Wait. Layer 1, mask 1. So it's getting blocked by objects that have a layer of 1. Okay. What about key? Wall, floor, layer, mask, right? I mean, this is supposed to work. I don't get it. Round. Rigid body won't detect. Do I have a video, maybe? Collision barely collides. Yeah. Godot 2D. Character body 2D. Make ground. I think it's just not going to stop. Not using real velocity. Well, actually it's supposed to collide and slide. That's what's really getting me. I really don't understand this.
Hey, I'm Siphon. Today we're gonna
create it's working.
Slide mechanic.
Hello. Show me your code. Show me everything. Wait, that's not English. Anyway, we have the character. Normal shape, sliding shape. Okay. What about your ground? Give me your ground. Oh, he's making like something a bit different. Handle player, wait. Yeah, he's doing something a bit more complicated. Player jumping and gravity. Okay, one bit, wait. That looks nice. So we have the player. Hey. Great. I like players too. Jump input. Wait, do you even show what you... So you have a tilemap layer. So collisions are handled by the tilemap layer. Really? Are you really going to do that? He is. Without time lapse. Hitting the collision seams between the small time-lapse cell shapes. Na, na, na. Let's try on YouTube, maybe? Because I'm just following on Reddit videos. At collision to sprite 2D. This is a okay. Full guide to 2D collisions. Okay, show me, please. Oh. So what is that? I think it should be on the same layer. I think that's like really the problem. Static body 2D. Because it's gonna work well here. But probably because this is like they're like children of the same node. But I don't think it's because of that, but I feel like if I do that, it's probably going to work for me. I mean, I can try, right? Rigid body. We have, wait, this is not a rigid body. Wait, what? What did he have? Collision polygon? No, before that. Static. Oh, I'm so stupid! I forgot that it was called static body. Yeah, this is not a rigid body, this is a static one. Let's try again. Yeah, this is a static body. Okay, now it works. But it doesn't work with my fingers though. It's ignoring. And this is kind of bad. Wait, what? Oh, it's not, there's no velocity anymore, right? I forgot. Because I'm just setting it at the beginning, right? Ooh. I like that. I really have to make my sprite. Okay. What should I do? I mean, I'm probably just going to do what I was doing before. I'm going to remove this. I'm going to remove this. I'm going to have key positions this time, and I'm going to update the key positions. So at first we have, let's say, this dot resize this. I mean, it should be the case. The size shouldn't change. So for I in range, size, I do this I equals keys I dot global position. And from now on, every time I see a global position, I should update it. Wait, I should do this. I should do this. I should do this. And at the end I have this, but this is going to change. Maybe, maybe not. Violet. I'm going to update that too. This, remove. Okay, should be good. And the last one is b dot no. So instead, yeah, I'm just getting the position every time, so let's have like I, B, J, right? Yeah, J. And this is J, I, right? And now I should be able to remove this. And compute area, wait. Wait, I mean that's supposed to be fine, right? Wait, no. Oh. Compute area. I guess it's not. Because I'm looping multiple times to check to solve to resolve, how do you call that? Resolve the constraint. The constraints. So I should be using the variable I'm using. If that makes sense. Okay. Okay, I should be good. So now I'm setting at the start of the frame everything. I'm computing stuff. And at the end, I want to set the basically target's position. Well, let's first try for I in range. Here's that size. We have keys I.global position equal this. And it should be the same. It should be the same. Nothing should change compared to before. The code should, yeah, it's behaving the same, right? As you can see. So this is still working well. And what I want now is instead of setting the global position directly, I want to set the velocity. And the reason for that is, so actually I'm not sure it's gonna work well. Maybe I should have, anyway, yeah, I want to set the velocity. Wait, velocity, where am I moving? Am I moving them at the beginning? Wait, what? Wait, move, where am I putting this? Oh, I'm just setting the position. Yeah, okay, never mind. Okay. So I have the velocity, right? Well, so I have the target position. My bad. Wait, what? Wait, how is it? It's not supposed to work, right? Yeah, because I just replaced this. Okay, fine. So this is delta. This is the target. This is the current. So this is going to be the velocity. Then I'm going to have, I'm just going to move those. So just that velocity equal velocity, let's say. Vector 2D. Could not find. Oh, vector 2, my bad. And then I want to move and slide. Or maybe collide. And I want it... Yeah, I just want to do that actually. Probably. Is it going to work? No, it's not. Because I need to take... Well, this is not... Well, actually, is it? Yeah, this is weird now, as you can see. So I have to divide by the delta time, because it's going to multiply by the delta time to actually set it. Hopefully this is fine. Wait, this is actually fine, but this is maybe a bit too fast. What do you think? Wait, actually this is just fine. And now if I go on the ground, it's working! Well, it's going through the ground right now. But this is working, kind of. doesn't want to go out. Okay. Yeah, some problems, right? It's a bit too fast sometimes. But I mean, it's great. It's like colliding with the ground. Oh, that was the end of the ground. That's not because it was too fast. As you can see. I can't actually go through because these are 2D collisions, so they're continuous. Yeah, they're 3D circle collisions. Yeah, okay, it's because they're circle collisions actually. Circle, rectangle collisions, so you can have a continuous collision without losing too much performance. Oh, this is so great. Wait, I love this. So now I have my little... Oh, this is so great. This is so great. So wait, if input dot mouse... What? Left? Probably. If I do this... Let's see. So here we go. Oh. It was falling down. And we have a soft body. That's jumping around, kind of. It's sliding a lot, though. I don't have any drag. I should add some drag. This is kind of bad. But I mean, the soft body is working well in itself, right? What I can do is I can reduce the sprite. I mean, that's not really the sprite I wanna change. This is more, maybe 15. And I'm gonna divide this by 2, let's say. Wait, what? So that was 30. Oh, radius. Oh! So if I want it to be exact, it's like 15. But actually, it's like a bit less, right? So maybe just 32. Oh no, I broke everything. Oh wait, that's normal. 2 AM. Past 2 AM. Okay, so here we go. We have the soft body. I could add even more points. Wait, I have one under the collider. It's moving. Okay, it's kind of really funny. I like it. Let's add more keys. Should we? Should we? Yeah. Okay, 50. Let's go with 5 times more. It's getting crazy. Yeah, wait, this is kind of crazy now. Yeah, this is really bad. Okay. Radius. Max distance. Let's have a 10, I guess. Dividing by 10. Okay, yeah, so now this is working. Wait, this is kind of wrong though. This is working weird. This is weird. Yeah, there are some weird things. Oh, this is because the size. This is because of the size. The minimum distance. I guess it's like too much actually. For the size of each little sphere. Let's just do 20 maybe? Yeah, 20 might be actually too much too. Yeah, no, this is actually fine. 20 is still fine. No, it's not. They are like, oh wait, it's because of the area. I have to increase the desired area. Maybe? Do I? Times 10? This is going to be like so big though. Is it really going to work? Oh wait, this is kind of working. But then it's like moving apart. Oh, it's because of the delta time though. It's because I'm dividing by the delta. I think it's like doing a lot of bad things, let's say. So what if I divide by 2 afterwards? This is actually good. No, this is not. Yeah, this is a mistake, I suppose. Let's just do this for now. So it's not going to collide though. But it should come back to me. Maybe not. Wait. Let's remove 1. Okay, so this is back. But it's like really bad. Because it depends on the area. I get it. So the more points, the less, the worse it is. It's trying to keep the shape, but it's actually not. It's just... Wait, actually, wait. Well, there's some like really strong interaction when it's detecting that's the... that is less than the desired size. I don't understand why. Area speed. Is that because of this? Delta area. So this is normalized, so that should be between 0 and 1. Delta area. This is the maximum between the two. This is probably why. Let's try just adding 1, 0. Let's see what it does. I guess, I mean, this feels a bit better, but this feels really... I mean, yeah, this is more stable, at least. This is more stable. But it's not keeping the area. So what if instead I put 1, 0 there now? Wait, this is kind of working now. And I'm keeping the shape. I'm keeping the shape. Oh. Yeah, this is really bouncy. I like that. So what if I set the velocity again? Instead of the position? And now that there is a collision. Oh. Yes! 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 I can't wait to put some visuals to it. I love it. I love it so much. Oh, this is working so great. I love it. I could just make, I mean, it's a bit late, so maybe next time, but I could just make, basically the plan is now to make, wait, let's go through the collider here. The goal is to generate a mesh from all the points, from all the keys, and put some shader on it. And maybe put some like outline, like the outline I made the other time. And put some eyes, put some visuals, and have like some sprite or something like that. Maybe next time. I love it. I have my soft body finally. Finally I have my soft body. And I guess what I want, velocity. I guess I can just multiply this by like 0 times 9. So we have some, it's like stopping, right? No. I mean, this is kind of working well. This is working well. The gravity is not there though. Because of this, I feel like. Mm, wait, gravity is still there. And the drag is working, okay. Okay, drag is working. Yeah, do we feel like we have... I really want to check the acceleration, the gravity. Does it feel like we have gravity? Yeah, okay. Yeah, it gains in acceleration, then it... Okay, I like that so much. Oh, I like that so much. This is so great. This is so great. I actually want to make it now. Do I have the time? Oh god. Do I have... You know what? I really want to push it. I really want to push it. Let me push this. Um, Let me call it soft body something. Private. This one is... let's add a readme license. No, I guess. Git ignore GD script. Oh, I don't. Well, Godot. Yeah, Godot. Okay. So now I'll go there. Oh. Let's go to there. I'm gonna have... Twitch overlay. Okay. Let's copy the Godot project. Sorry about that. Clone. Okay, I think we have it. So here we go. I just cloned the project there. So as you can see, I have everything. So I actually have a trick with Git that I wanted to show you. The trick is that you can just move this in the folder you want your Git to be. So let's ignore, let's say. I already had a Git ignore. So now I can go here, remove soft body twitch overlay, and now I can just go on the terminal, git status, and I can just push right away. I just close scenes. So overlay means it's like, well, never mind. I mean, this thing is basically that it's a temporary for when you play the scene, for like the editor or something, so I don't want to push it. I mean, I guess I can push that. I guess I should have... Okay, let's get the git ignore. I have some editor config and stuff, I'm not sure I want them. Yeah, maybe I do. Let's add everything. Except maybe... icon. I don't need that. Well, trash is trash, but this is fine. Let's reset the temp. And I guess that's gonna be it. Overlay. Let's go over... overlay. Maybe? Overlay. Overlay. Oh, wait. Overlay. Yeah, overlay is fine. And this is gonna be soft body physics. I did. Here we go. Done. I'm. You know what? It's gonna be too late. If I do something else, it's gonna really be too late. So I'll probably be going now. Wait, I have something. Wait, I wanna try something.
Uh-huh. Yeah.
Oh, never mind. Well, let's just rage. I'm gonna show next time. So let's raid. Here we go. And thanks for watching, everyone. Some of the buddies are just so good. Maybe next time, I mean, I'm gonna go back to my project about cards and stuff, my card game. But I guess I really wanted to make my soft body physics. I just love it. Look at this. This is so great. Oh, it disappeared. Ah, it fell. Look at this. Anyway, thanks everyone, and see you next time.